Hey, we are winding down the year, 8M6 lesson 12, nonlinear models in a data context. And as often as we get near the end of these lessons or these units, there's some optional lessons that you may or may not be doing in class. So some of you may not be doing this lesson at all, but if your teacher is asking you to do this lesson, I am here to support you in that effort. And I have a new example that you can use in addition to lesson 12 that will present a nonlinear model of data. And it's actually a kind of fun one. There's a video that goes along with it that I found on the internet that you can use and look at. It's about some kids that are catching basketballs falling off of tall buildings, which is kind of funny to watch. I highly recommend it. Well, let's go through to this example, and after we're done with this example, I'm also going to bring you back to Desmos to show you how you can model this nonlinear data as well. Okay, let's get on to this is hopefully a relatively short lesson. It's one example, a little bit of me talking, and hopefully it makes a lot of sense to you. Okay, so as we know, two variables may have a correlation that's not linear. So often what we're doing these days is we're looking at data has a linear relationship. So we'll have data that, I don't know, looks something like this, and it can be modeled really neatly with roughly a straight line, and then this will have some best fit line that looks like this. It looks like y equals mx plus b, and it will be, you can model all estimates for the data off of this line. So if I wanted to say, well, if this is, if my data points were like 1, 2, 3, 4, and 5, and this was time, and this was distance, 10, 20, 30, 40, 50, we could say how far, and that would say in feet, how far, after 3 seconds does an object go, right? We can ask this question, and we can say, well, given our best fit line, we can just draw our line up and over, and we could say probably about 38 feet. And then we could answer the question, with 5 seconds, and then after 5 seconds, maybe it would go 60 feet. And this would be a nice linear model. Now, we're going to talk about a relationship where this data is not linear. And we'll show, a good example. We'll have it's a real world example, and you'll see what we're talking about. Now, we're not going to find that best fit line or the equation of that best fit curve, but you'll see what we mean. And let's move forward to that example. Okay, now, Mr. Lipscomb, so that's me, I gave an assignment project in class to propose an experiment that would identify two correlated variables that did not have a linear relationship. So you had to make a guess about something that didn't have a linear relationship. Then run an experiment to show that the relationship was not linear. So that was kind of the homework assignment. And I assigned, pairs of people, and Jose and Ginger thought about it, and they said, well, I think if we drop a ball off of a rooftop, it would not have a linear relationship. In other words, after 1 second, it might fall some distance, like 30 feet. But after 2 seconds, it wouldn't fall another 30 feet. It would fall further than that. It might be like 90 feet. And after 3 seconds, it might fall even faster because it should be going faster and faster. So like after 1 second, it might be here. After 2 seconds, it might be here. And after 3 seconds, it might be all the way down here. Because we think that ball is going to be speeding up. And so that at any given 1 second interval, it's going to start falling further and further. And at least that's what they proposed. So Jose and Ginger thought about it and said, we think it's going to fall faster. So their independent variable, they thought would be time. So in time in seconds, that's their x. And then their y would be the distance. And rather than measure it in feet, they thought they could just measure it in floors, because all floors are about 10 feet. So that would be a fair way of measuring an equal amount of distance. So they were going to, figure out how far did it fall after half a second, how far did it fall after a second. And what they were going to do, they would use an iPhone to record the data. And then they could stop their iPhone every half a second and then see where the ball was. And then after a half a second, see where the ball was. And then after half a second, see where the ball was. And they would keep doing that. And then they'd measure all these distances. That was their idea. Well, what did they do? They got smart. So Jose and Ginger actually got smart. And what they did is they went and found a video on the internet. And that was, you can actually go to this URL right here. Go to this URL right here, and you can type in this youtube.com/watch ? V equals VE4EU. Type this in, and you're going to see some guys dropping a ball from a rooftop, and they're throwing a basketball off the rooftop and actually trying to catch it, which I don't recommend you do. Do not do this at home, as they say. But at any rate, they recorded this data. They stopped the video at 0 seconds. Yeah, 0 seconds. And then they stopped at 0.5 after the guy throws it, again, drops it off the roof. And then 1 second, and it had fallen 1.5. And then after 1.5 seconds, they actually forgot to record the data. They forgot. And this is kind of my puzzle to you. They forgot to record this data. And then after 2 seconds, it had gone 6.5 floors. So they were kind of right. Notice in the first second, it fell 1.5 floors. And in the second second, it fell 5 floors. And how far did it fall from the second to the third second? It fell even further. It fell 8. So it's falling further and further every second as it goes down. So what I want you to do is do these 3 things. I want you to graph the data. I want you to draw a best fit curve. Now, it's not straight. This will not be a straight line. It will not be a straight line. And then I want you to guess, because, again, they forgot to record this data here. I want you to guess, using your best fit curve, how many floors you think it fell. And then we're going to go get the real answer by using this tool called Desmos that we looked at yesterday. Okay, so now this is your homework help. Now I want you to pause and try, A, B, and C right here. Okay, now I assume you're back. So let's graph this data. Let's go 0, 0, a half, comma, a half, 1, comma, 1.5. We forgot to do 1.5, so let's do 2.0 and 6.5. 2.5 and 10.0. And then 3 seconds and 14.5. So I think you can see that this is not, this data is not modeled by a straight line, because if I tried to model it with a straight line, I'd get something like this, and that clearly isn't right. Because, is it like this? Is it like this? It's really not the right line. So let's see if we try and sketch this instead with let's use a different color. Let's use orange. So here, let's look at it like this. We get kind of a curved line here. Notice how it's kind of curved. And we're going to get a straighter line when I show you a better tool for doing this. If you have a better sketching hand, you may have done a better job of this than me. Let's try it. That's a little bit better of a line. Okay, so we've graphed the data. We've drawn our best fit curve, and notice it's a nice curve, and it starts getting steeper and steeper and steeper and steeper. And now after 1.5 seconds, let's predict the distance. If we just looked at this chart over here and we guessed the distance, we might guess 4, we might guess 3, we might guess, even 2, because, things are slow, then start going faster. We don't know what the line is, but now that we have a best fit curve, we can do a pretty good job of guessing after 1.5 right here. So that's 1.5, and so this right here is 3.5. So we're going to guess 3.5, and I think that's a pretty good guess. 3.5 floors. And so let's happy cat that, because I'm pretty confident. Whoops, happy cow. Man, always reverting to that silly cow. All right. So let's happy cat that curve. Let's happy cat the line, and let's happy cat the 3.5 floors. Now what I'm going to do is I'm going to go over to the tool, desmos.com, where we can actually graph it. Now I have put up the data that I gave you, and we can actually graph that here. And so we can see this line here. Now to draw the best fit line, I know something that you don't know, because I've had physics and I've had some advanced math. So I know that this line is a kind of an x squared kind of line. So typically if we said we want to draw this, is that let's do it as we learned yesterday. Let's pretend that it's a line. And let's see what the best fit line would be. So we say y1, and then we do that tilde thing, and then we say mx1 mx1 plus b. Now this is our best fit line, this blue line here. Do we think that line is a good line? Well, I don't think so. And in fact, I mean, our R squared isn't that bad. It's like a 0.9, so it's kind of it's an okay fit. But let's see if there's yet a better fit. And I'm going to propose that we have y1 equals an mx1 squared plus b. And that's the way things fall in space. And I just know that because I've had advanced physics and advanced math. So we're going to pretend, well, what would happen if we said mx1 squared plus b? Well, now we look at this curve. Look at this black curve. Let's hide this line here, which was kind of off in many places. But let's look at this line. Does this look like a better fit? I think it does. I think this looks like a really good fit. And they're telling us that our R squared here is a 1, which is what they call a perfect fit. So we have a line that looks like this. So let's see, what would our data be if, now I'm holding down on this curve. I'm holding down on my mouse, and I'm finding out each point along this curve. So if we went to 1.5, we would get 3.6. 3.6 would be our number, and we guessed 3.5 on our curve. So we did a pretty good job with our curve fit. Remember, we guessed that it might be about 3.5. And the official tool with the advanced, so using advanced knowledge of physics, advanced calculus, and some powerful charting tools, we found out that the real answer was 3.6. And our guess, just knowing 8th grade algebra and drawing curves and doing best fit curves in our mind or on paper, and then doing some estimates, we got 3.5 floors. So we did pretty good knowing just quote, just our 8th grade math. So we're going to end it here. Hopefully this was a fun lesson. Hopefully you enjoyed watching the video of I think they're Australian kids that were throwing basketballs down in the Philippines. Don't try this at home. And that this was a good lesson. We have 2 lessons to go in 8M6, and we will be done with the school year, and that will be that. And you'll be on to more advanced math. There we go. Congratulations to you. We'll talk to you next time.